Hello everyone, good evening. So today we are going to start with a project for cloud native application of React.js deployment on AWS EC2 instance using Terraform infrastructure as a code. So if you can see my screen, okay, so this is basically the architecture of the project that we are going to conduct today. So we are going to deploy a online boutique application, e-commerce application on Amazon AWS EC2 instance using GitHub Actions as a CI/CD for workflow automation, and deploy it on the EC2 using Terraform infrastructure as a code. So we don't have to do anything manually, but we are going to do everything on our using the infrastructure as a code. Okay, so this is basically a React application. It will go through the GitHub Actions workflow in which it will provision through Terraform, like the initial stages of Terraform, initializations, the plannings, the apply of the entire code, and basically Docker containerization of the image. So we are going to containerize our application using Docker, push that Docker image on the Docker Hub, and from that Docker Hub, the EC2 will fetch that image and it will get deployed on the EC2 instance. Once everything is done successfully, a user is going to get an email notification. So here we are going to configure our Gmail address on which we will get notified of our the workflow if it is successful or failures. Okay, so let's get started. We will deep dive into the code base of this application, and I'll walk you through the code base as quickly as possible. So this is our React.js application with Bootstrap as framework using Vite. Okay, so this has an index page. Okay, where div id is root. Here the application is fetched as a component directly into this root. Okay. Okay, so basically what we are going to do is, okay, this is my code base. Okay, this is the index.html. Okay, so this is basically the entry point. It has a single div id is equal to root, where React injects this entire application. Okay, so the source main.js here, source. Okay, the main.jsx file, this is the JavaScript entry point. It finds that the root div and renders this application, okay, as a component inside this. So it also wraps the browser router to enable the navigation. Okay, so the data layer of the context API here, what we are doing here is, instead of passing the data manually between pages, we are using context to make the data global. Okay, so the source content, shopping content item, okay, the .jsx files here, we are going to fetch the product data from this js file. Okay, product data.js, and make it available everywhere. So source context shopping cart context.jsx, this is basically the brain of the store. So it has all the information like the cart items, what the user has added, the functions, the get quantity, the remove quantity, decrease, increase. Okay, and the local storage, that it saves the cart to the browser storage, so it persists the data. The data is persistent if you have removed it or you have kept it. Okay, so the source data product.js, it's a specialized file that acts as a database. Okay, and it contains an array of products. Like now if you see, this is the online shopping application, which I'm going to show you a local image of the application which I have built. So basically this is the application that I had built. Okay, and if you want to take a glimpse of the uh, shop that we were using, this is the image. It's running on port 3000. Okay, so basically I have built the application locally for you to have a glimpse of it. This is the application image that I had built, and if you want to see how it looks, it will be like this. Okay, so here it's an online e-commerce store application, basically, with different sections like store, which has entire array of products, and the quantities, the pricings available. If you add this to cart, then the cart quantity gets increased. If you add this, okay, all these things, whatever basically the women fashion essentials and cosmetics that are included as a part of this products. Okay, so I have named it with my name. Okay, and here that's why I have added all my personal details here as well. Like this is my GitHub repository link, then this will host my portfolio link. If somebody clicks and they can check my portfolio, and this is the card details. So here is the hamburger icon as well. So these are settings for light and dark theme. Okay, so this is the React.js application that we are going to deploy. This is a local image which is running on localhost port 3000. So now let's get this deployed on the cloud. Okay, so how we are going to start with that? Okay, this is my AWS console, and I am logged in with my IAM user Neelam underscore TF. So I have my security credentials already downloaded and set it in the GitHub secrets and variables. I will show you the EC2 instances. Right now we don't have any EC2 instance provisioned here. Okay, in this region US East 1, and we are going to use the same region for our infrastructure provisioning. Also, I'll show you that there are no S3 buckets that we are going to configure as backends for storing the Terraform state files. So there are no buckets here. Okay. Now, what we are going to do basically is containerize our application. So this is my code base. Okay. This is the entire folder in which our application code is there, and the Docker file is there. In order to containerize it, we'll build this image and push it on the Docker Hub. So I'll show you the Docker Hub as well. Okay, so this is my Docker Hub. Okay, and we have will build and push the latest image on this Docker Hub. So you can see the previous image which I had pushed is like some few hours ago, 13 hours ago. So this will be replaced by the newly built image that we are going to build right now using the GitHub Actions workflow. So this is the workflow file that we are going to write. Two files that we are going to write today. One will be for building the infrastructure, and one will be for the destruction of the infrastructure. Okay, so basically, okay, so what is the data source that we are going to use over here? So the product data.js file is going to act as a database for us. Okay, the UI components like the footers, the navigation bars, the routes from which the application is going to navigate, the user is going to navigate, is all stored here, like menus, mobile responsiveness, and everything. Main shopping page, it loops through the product data and the store item for each product. Okay, so src components store items.jsx is the file that we are going to use for that. Okay, and the reusable card showing the product images, the pricing, and this because that card is going to get reused for us. So this is basically our application. Now we are going to look at the Docker file, uh, for which we through which we can containerize our application. So what the Docker file is going to do? So basically this Docker file is going to fetch a lightweight node.js image. Okay, and it will start with alpine node 20 as an image. It will copy all the package.json and install all npm install dependencies, copy the rest of the code to the current working directory, and it is going to expose this port 3000 and run the npm dev run dev commands basically to start the application. So this is how it is going to package our application, entirely build and containerize this. Okay, then the CI/CD, it will be, this is like the GitHub action workflows are going to run on the Ubuntu, the GitHub hosted runners. And as soon as we push something to the master branch, this main branch or master branch, this is going to start the actions. Okay, and we are going to check out I mean the backend state of the Terraform file using the S3 bucket. Okay, that we are going to also provision using this infrastructure as a code. So let me walk you through the CI/CD basically in the GitHub repository. Okay, so this is my GitHub Actions workflow file. Here, what we are going to do is we are naming the job as CI/CD pipeline. There are various jobs like on building and pushing to the master image, sorry, branch. We are going to start the trigger. So this is configuring the Terraform backend, checking out the repository, setting up Terraform, verifying the AWS credentials, access key, secret access key, and configuring those credentials with region. Okay, and then what we are going to do here is test the AWS configuration by listing their S3 bucket. So whichever buckets we are going to create, that the name of the bucket should be very unique. So that's why we are variabilizing the bucket creation here. Okay, and if we are checking it whether the backend create backend is true or false. If the bucket exists, then it will not create a new one, and if it doesn't exist, then it will create a new one. Okay, and then initialize the Terraform backend. So basically we are using DynamoDB table for locking our Terraform state file, because we need to, as you know, we have to keep the state file very secure, and hence we are locking it in some remote place like S3 bucket, and the using the lock id hash id of the DynamoDB table, so that everything we can do through the console as well, but we are doing it through Terraform in order to provision everything as a code. Okay, then we are provisioning these resources, and then Terraform initialization, planning, and execution is happening here. Output variables is going to give us the output public IP of the EC2 instance. We have stored everything in the Terraform folder here. If you see the Terraform resources here, so here we are going to configure the providers. AWS provider from HashiCorp with version 5.86 is used here, and the bucket name that we are going to provide today, okay, with the region DynamoDB table name as well. Okay, in this region, this is the provider configuration. Then this is a variable file where everything is variabilized, and in the main file we don't have to hard code anything. Later on, if we have to do any changes in the Terraform file, then we can go and change in the variables, and without having the need to hard code it somewhere else. So if we change it in one place, it will get applicable to other places as well. Okay, so this is the data block, the key pair generation resource, AWS default VPC, ingress egress rules, so that I mean inbound outbound rules for which the Terraform, the EC2 instance should allow the traffic. So it TCP port, SSH port, and HTTP port are allowed. Okay, and this is the 3000 port, which is the application port. Sorry, application port on which the application is going to run. Okay, and this is the EC2 instance creation block. Okay, volume size is the storage area that it is using on the storage instance. Okay, this is the outputs.tf. We are getting the output for private and public IP of that EC2 instance. Okay, and this is the action, this is the SSH keygen public key that we are going to store in this file. Okay, later on we are configuring the backend. Here backend infra, we are providing the same S3 bucket configurations here managed by GitHub Actions, and the DynamoDB table configurations that we are using for as a lock ID, and type is a S. So the tags and the lifecycle ignore changes is set as true, so that we don't do any destruction changes to the uh, this infrastructure backend and DynamoDB table. Okay, so this entire Terraform is set up using these two folders. Then we will go and uh, start running our uh, building our infrastructure. Okay, so now let's see what secrets we have to add. So this is our repository, and we are going to add few secrets that I'll show you here. Okay, so basically AWS secret key, secret access key, DynamoDB table name, S3 bucket name, Docker Hub username, password, EC2 SSH private key, and mail and username of the email on which you are going to get the notification. Okay, so we'll first open our terminal. Okay, we have generated this SSH key. Now what we are going to do is we are going to override this existing SSH key, because we need to SSH the new instance. Okay, so what we are going to do now is, okay, so now basically we are generating the SSH public key and private key. Okay, we have to override the existing one, yes, because we have to use the new ones. Okay, let's check uh, what are the contents of the public key. Okay, this is the private key. Okay, okay, okay. Okay, so I have copy pasted this SSH private key into the GitHub and I am going to continue. Okay, so this is my private key which I have added, and now in our repository we have a public folder, public key file in which we have to go ahead and add our public key there. Okay, so this is the file in which we have to add our generated public key. This was the private key. Now we'll okay, so we'll copy these contents and update this file. Okay, then we are going to commit these changes to the master branch. Okay, so once we commit something to the master branch, the immediate GitHub Actions uh, workflow is going to start. So let's see what are the stages that we are going to face in this workflow. So first of all, it is going through this setting up of the job, initialization of the Terraform, okay, and planning of the Terraform is happening here. Okay, as you can see here, creation of the S3 bucket is in progress. After that, checking out the repository. Now it is provisioning the resources. So what it will provision is, it will first install the AWS CLI, initialize resources with the backend. Backend is S3. So now it has initialized successfully. It is planning the infrastructure. So what needs to be added, what C4 things are will be added. Four things in the sense, the EC2, DynamoDB table, S3 backend, and the VPC. Okay, all these resources are now in progress, and it will get the EC2 public IP for us. After configuring the AWS credentials, it will go to the next step of building the Docker image and pushing it to the GitHub. So as you can see here, it is building and pushing the Docker image. Okay, so it gives us few more warnings for deprecations, but we can ignore them. Okay, and we can easily use Docker in debug mode to check what are the deprecation warnings that we are facing, and we can improve on that. So now it is deploying our application on the EC2. Okay, it is fetching that latest image which is pushed on the Docker image, Docker hub, and then deploying it on the EC2. See, US East 1. Okay, so this is deploying our application. So first it will install Docker on our EC2, deploy that container, and after the checkout, the container is clean. So see, and then the email will be sent regarding the status of the deployment of the workflow. So our entire workflow is in action now. So using the instance public IP and that port 3000 which we have used for containerizing. So on that containers 3000 port using the public IP, we will be able to launch our application on cloud, AWS. Okay, so notification it has not sent because I did not set up my app password from Gmail, but I just have set up my email ID. Okay, although it has deployed on the EC2, we can go ahead and check. So this is my AWS. Where is it? Okay. Okay. So here, if you can see, okay. So here is my AWS account on which you can see that it has provisioned this S3 bucket. Let's check out the S3 bucket. Okay, here the state file is stored. If you can see, this is the state file. It is stored here. Okay, terraform.tf state. Now we'll go and see if it has provisioned the EC2. Yes. Okay, this is the instance which is running. Okay, see, this is the instance that we provisioned. This is the public IP of the instance, the security groups, and all the settings for inbound, outbound rules is in place. See, these ports we provisioned. So everything that we wrote as a code in Terraform, it came into life in AWS console. That is the magic of HashiCorp Terraform. So let's take this public IP now, and let's check if we can get our application on port 3000. Okay, so it has the security warning, and see, yay, we have deployed our application successfully using Terraform on AWS EC2 instance using its public IP. Okay, and it's running successfully on port 3000. See, it is adding the number of items, the however number of cards I'm appending, it is adding. Okay, so these many I have. This is the admin section. You can write, can add any product. Okay, then, okay, anything you can add here, the image URL, and you can add the image here. This is the light and dark mode. Okay, this is my portfolio. So all the hyperlinks are working as well. This is my GitHub repository link. It is also working. Okay, these are the card details. So this is how we provision infrastructure using EC2 instance. So let's go and destroy also whatever we have provisioned. So we'll basically run our destroy.yaml CI/CD workflow. What it has is, I'll walk you through that. So it will destroy everything on running on the Ubuntu latest agent. We will provide a branch name and provide destroy as the instructions on the fly, and it will fetch all these credentials, AWS access key, secret access key, the region, and initialize the Terraform resources for destruction. So basically Terraform init. Okay, and destroy auto approve. This will be the command that will be passed in this. Later on, we will clean up the temporary files that will be generated during the destructions. Okay, then checking out setup Terraform, configure AWS credentials, initializing backend we had set up S3 bucket as a backend and DynamoDB. So all those resources will be destroyed as well. Okay, so import empty and destroy backend resources. This is the step which will destroy everything. The log files and everything will be output on this. Okay, and then send notification. This step need not pass because I have not set up my Gmail password. Only I have set up my email username. Okay, but if you are too keen, then you can go to the app passwords of your Google account and set up that app password in the secrets in the repository of this app workflow. Okay, so we will go ahead and run this destruction workflow. Okay, we'll put destroy and run. So it is going to destroy everything. One thing I forgot to tell you is that this is the Docker image. Okay, in the Docker hub that I'm going to show you. Okay, okay. So this is the Docker image that was pushed 9 minutes ago. Okay, the earlier one was 13 hours ago, which I showed you in the previous section of this video. Okay, so this is going to destroy the entire infrastructure. It's planning what all resources will be destroyed. Okay, so you can see it is planning to destroy 4 resources. The 4 resources that we had created earlier, they are going to get destroyed in this. Okay, so that is how Terraform is fetching the recent state from the S3 bucket using the DynamoDB, and it is locking the state in that hash value. Okay, so now you can see one job is successful, the other one is still in progress. So it is initializing the backend, provider plugins are initialized, Terraform init is done, debugging whether the S3 buckets are there, debugging and it is listing the DynamoDB tables, importing the S3 bucket if it is existing, okay, and importing the DynamoDB table. Now it will empty up that S3 bucket and it destroy the backend resources using Terraform destroy hyphen hyphen auto approve flag. Okay, so that is how post configuration is also done for the AWS credentials of the user and the EC2 instance SSH keys that we have passed to the GitHub secrets and variables. Okay, so we can see that these steps are successful. This step, as I said, this will not pass because we have not set up the password for this. Okay, so but we can go and check now that our this thing is the EC2, there are no EC2 running instances, it has disappeared. Okay, there is no EC2 instance now. Okay, because a Terraform destroyed everything. There must not be any buckets also here. Okay, no buckets and no DynamoDB table as well. Okay, so this is how we are using IAC for deployments on AWS cloud, and the CI/CD workflows are performed using GitHub Actions. So if you like this video, please like, share and subscribe to this channel. And if you have any comments or feedback, please let me know in the comment section of this video. Okay, thank you everyone. Thanks for watching. See you all in the next video. Bye.